Welcome students to the series of lecture on the large language model. And we are trying to build the large language model from scratch. And today in the series of lecture, we are entering into self-attention mechanism, and actually not completely into self-attention mechanism because there are different complexity associated to self-attention mechanism. We have to understand four different self-attention mechanism, and we'll start with the most simplest one. And it is quite intuitive to enter into the discussion of the self-attention mechanism because we have completed tokenization, we have completed vector embedding, we have completed positional embedding, and the next course of the journey is self-attention mechanism. But I thought, let's talk about the journey that why people have moved from neural network to self-attention mechanism. What was the problem in the sequential neural network translation mechanism, and why we have to design encoder, decoder, and then attention and then self-attention mechanism. So in today's lecture, we'll try to focus on that journey, not the algorithm of the self-attention mechanism. Okay. So in the old days, neural network were being used for the translation task to convert the sentences from one language to another language. So assume that you have a sentence, then the neural network were being tested or trained to convert that into a different language. It could be German, it could be French. Okay, so the sequence to sequence model, the neural network sequence to sequence model would try to convert one token or one word into a different language into another language. Assume this is the sentence. Can you help me with the chapter? So what will do this neural network, the old days neural network, what it will do that it will convert one word, it will take one word, convert it into another language. So it is can, it will convert it to kya. You, it will convert it into tum, Hindi. Help, they will convert it into madat. Me will convert it into meri, with into saath, the into vah or hai, any one of them, and chapter into adhyay. However, you can see that this is not working because the actual translation of the sentence is kya tum meri is adhyay mein madad karoge? Can you help me with this chapter or the chapter? So you can see that the sequence to sequence neural network model will not work because it doesn't have the context. I can simply say that it doesn't understand the grammar. But what is grammar? What is grammar? For the mathematical or in the language of machine learning, it is context. It is simply context. So it doesn't understand the context of this sentence. And because of that, it is not able to transform this sentence from English to Hindi. So in 2014, Google published a paper. The paper name was Sequence to Sequence Learning with Neural Network. This was that paper. Sequence to Sequence Learning with Neural Network. And they talked about encoder and decoder. But still, in the world of neural network, they were not talking about the self attention mechanism. They were not talking about self attention mechanism. They were still in the world of neural network. And they said, okay, we can use encoder and decoder. What? Encoder and decoder. The responsibility of encoder is to convert every word or every token into a hidden state. Into a hidden state. You can take that hidden state as a vector. Okay. So I will be converted into a hidden state. By whom? By the encoder. Then am will be converted into a hidden state 2, which will have some information about hidden state 1. Then A will be converted into hidden state 3, which will have the information about H1 and H2. Student will get converted into H4 and it will update the information of H3 into it. The final hidden state will be given to decoder, and then decoder will transform each word I am a student into Hindi. And this was working. This was working fine. But this was working fine if there are short sentences. For long sequence or long sentences, it was not working. Why? The reason was the problem they identified that you're only transferring the final hidden state, H4. Yes, it has certain information of H1, H2, H3, but you're only sending one vector which have all the information of all the hidden state or all the tokens, right? And because of that, they were not able to perform properly in long sentences. Assume there are H100 Assume there are H100 hidden state. Now H100 will definitely have some information of H1, but the information would be so bleak, would have so less information about H1 that it will lose the context. So it was not working for long sentences or long sequence. So in 2014, the first time the word attention came into picture, it was 2014 Bahdanau Attention paper. This was that paper, Bahdanau Attention paper. This talks about, first time this talked about dynamic focus, dynamic attention, dynamic weight. So this was the paper 2014, which was the first paper which ever talked about a dynamic attention. So you cannot say that the attention mechanism was given by Google in 2017 by attention, all you need, but actually it was this paper which introduced attention to the world. Okay. Again, it has the same encoder and decoder model. So encoder model responsibility was to convert each word into what? Hidden state. And decoder responsibility was to convert that hidden state into what? A different language. It could be Hindi. In Hindi, I'll convert it into मैं एक छात्र हूँ. This is the Hindi translation of this sentence. I'm a student. But what is different in this attention mechanism? Again, encoder was converting the complete sentence into what? A vector, or you can say hidden state h1, h2, h3, h4. These are hidden state. But this time, they're not just giving h4 to decoder. They are giving all the states, all the hidden states to the decoder. So when decoder is working on h1, say decoder is working on h1, which is the hidden state for I, it gives dynamic weights to different hidden state. So it will say, I'll give most focus to hidden state 1 because I'm talking about hidden state 1. Then I'll give most focus to say hidden state 4. It could be say 0.2. And then I'll give some focus to other hidden state. However, when this decoder will start working on H3, then it will give most focus to H3, some focus to H4, then some focus to H1 and H2, right? So actually, what they are trying to do, they are trying to convert the sentences into what? Vectors, which are hidden state, and they are giving all the vectors to the decoders, and then decoder is transforming the complete sentence. So what is simply happening? So instead of giving the final hidden state in the Bahdanau attention paper, you're giving all different hidden state to the decoder, and then decoder decide what weight to be given to which hidden state. Okay, and we'll try to see this. But what is the difference between attention and self-attention? In 2017, when paper self-attention came, the paper was not about translating from one language to other language. The paper was about predicting the next word in the same sentence. So the sentence is, I'm a student, and you have to predict the next word. You have to predict the next word, which could be of. I'm a student of arts. I'm a student of computer science, whatever. So you have to predict the next word. So you're not translating into two different sequences like that. You have to convert a sentence, I'm a student, into Hindi. You have to convert a sentence, I'm a student, into मैं एक छात्र हूँ. They're two different sequences, right? Here we are talking about the same sequence. I'm a student, and you're predicting the next word. So basically, you are trying to focus on what? One sequence. So therefore, yes, attention is there, but self-attention. Now, the decoder will assign a weight to different tokens. So if the decoder is thinking about or trying to analyze I, it will give 80% weight to I, 2.5% weight to am, 2.5% weight to A, and 15% weight to student. So what will happen in the self-attention mechanism or attention mechanism? They will try to assign weights. Why they're assigning weights? The weight is to tell where you need to focus. 80% weight means that you have to focus for 80% of the time to this token or this word. And that's why the word attention. So these weights are telling the decoder where you need to focus more. In self-attention, you are focusing on the same sequence. in the Bahdanau attention, it is just attention, it is not self attention. You're focusing on two different sequences. When you're trying to convert I into मैं, then मैं is focusing on I am a student with different weights. So therefore, attention, not self attention. Self attention means the focus given to the same sequence, same sentence, or the same token in the same sentence. Okay. Now we'll visually see that what is the difference between sequence to sequence model. Then you will see visually that what is the difference between the sequence to sequence model with encoder and decoder. Then you will see the difference between sequence to sequence model with encoder and decoder and with attention, but not self attention. Okay. So we'll see it visually. Just wait for a few seconds. So I found this very good visual representation of sequence to sequence model. Let's have a look. So what is happening in sequence to sequence model? So in sequence to sequence model, you gave three token and one by one, it is converting that token into the final translation. Okay. So now you can see you have three word in different language. So what actually happens? It will enter into the neural network. First, it will predict I, then am, then and then student. Okay. Now, what will happen? What will change in a encoder and decoder model? You will have hidden state and you will throw only the final hidden state. So let's see what happens. So all the tokens entered into encoder and the final context, the final hidden state enter into decoder and decoder translated that context into different words. Okay, let's see the proper representation with the help of hidden state. So this is hidden state 1, then hidden state 2, then you have hidden state 3. Now this final hidden state 3, which have the information, some information of hidden state 2 and 1, will be given to the decoder and decoder will convert it into the final English sentence. Okay. Now what we need that all the hidden state need to be transferred. Okay, let's see how this will happen. Let's see this visual. Okay. So you get the hidden state 1, then you get the hidden state 2, then you get the hidden state 3, then all the hidden state, not only hidden state 3, all the hidden state will be transferred to the decoder and decoder one by one translate the word into English or the sentence into English. Now this is representing, let's understand what's happening here. This is representing that when the decoder is using hidden state 1, it has hidden state 2 and hidden state 3. But most of the focus is on hidden state 1. Then when it is predicting the second word am, it has the focus 100%, not 100%, 80% of the focus in the hidden state 2, but it has some of the focus on hidden state 1 and hidden state 3. And you can also see that one of the boxes have a darker shade. See, this one has a darker shade than this one. This one has a darker shade than this one, which is highlighting where to focus more in other two boxes. Here you can see that in the third prediction, third word prediction A, it is giving focus to hidden state 2 and hidden state 3. Definitely it is giving more focus to hidden state 3. But yes, a lot of focus also given to hidden state 2. And then the lowest focus is on hidden state 1. So this was your Bahdanau attention mechanism. After that, things changed because they started giving attention to the same sequence, which is this sequence, not this. There are two different sequences. This is a sequence in a different language, and this is a sequence in an English language. Now, in the self-attention mechanism, which is the paper written in 2017, it talks about that you focus on one sequence. The logic is same, the approach is same, but you're focusing on the same sequence. So this was the difference between the attention, self-attention, then a neural network model, a neural network model with decoder and encoder architecture, and a plain vanilla sequential neural network model. With that, I'll pause here. Thank you. Have a nice day.